First, I would like to thank Milena and the whole organization behind this conference for organizing this really amazing conference. Uh, I discovered it 2 years ago, and I think it's really important that this conference continues this way because air pollution is a problem that is going to be there with us for next millennia. The way we are doing it right now and taking care of it is very bad, and we need to address these questions more often and more directly to government to push them to do something different. That's why this research is continuation of my PhD thesis, and basically it allows us to see future positions that we can apply and how can we prevent additional pollution to our environment. So basically, I will talk about you a little bit in introduction, a little bit about aims and goals, methods we performed, what we did about modeling, and some final remarks about our research. Well, urbanization and urban transformation processes are very active worldwide, especially when we are all connecting together. Cities are growing larger and the pollution is getting bigger and bigger. Besides traffic pollution, that is big problem in big cities, we also have construction sites, and we call it urban transformations. Everything that happens from creating a new building, demolition, reconstruction, actively generates particles and particle matter. So research from Canada has shown that particle pollution from urban transformation can actually be up to 20% of total particle pollution in the city. What is important? We are living in a developing country, so there is not a lot of adequate laws that characterize and regulates pollution that occurs. And we can also consider construction sites as an indicator of progress in every city. And that is really special for our city, Novi Sad, because at one moment in 2019, during COVID and after COVID, we had more than 200 active construction sites. Now imagine that for a city, that's a lot. And each construction site can be considered like a small point for particle emission. What is very special about particle emission from construction site? Beside creating severe pollution, it also collects all the other metals that are emitted during construction processes. What is required for us and for everyone to do? So we need to have some different approach. We need to have holistic approach, understanding on not only the air pollution that we are producing from construction sites, but also understanding what we do to soil, what we do to water and underground water sources. And of course, understanding how we influence other environmental elements, such as other buildings in the environment. Particles can be, PM particles can be very big problem for existing buildings. They can damage or create large problems for other buildings that are already existing in the environment. And very important problem is approaches in the constructions. Are we going to take traditional or modern approach? Is there a modern approach in the form of preparing for pollution, understanding pollution, or just doing it and don't care about pollution? Most of our research has shown that engineers that are working at the construction site don't care about air pollution. They only care about being done on time and don't care about health hazards that are possible for the workers. So we need to educate our engineers, change regulations and legislations, and teach them about particle emission that occurs on the construction sites. Also, most of the people consider particle emission as a dust, like something normal and not the problematic. But problem is that emitted particle emission from construction sites actually has a lot of PM 2.5 and PM 10 particles inside. So the traces we see on our cars if we park near construction sites is just a small tip of the iceberg. The problem is that we inhale a lot of those particles and they absorb on them a lot of metals and different polluting substances that are very dangerous for us. And as my colleague previously said, they are now considered one of the top cancer signals. So as I said, during the construction, we have earthworks. So basically everything that has connection with soil produces extremely large amounts of pollution. Also during construction, transport, fine works, and other miscellaneous works, we have a really large number, very high concentration of particles in the air. As you can see here, every position on the building during construction produces particles. What we did, so we had a 5-day monitoring campaign, and we used OPC N2 sensor. It's optical particle counter made by AlphaSense, and due to requirements and working habits of this sensor, we had to watch not to have too large humidity. So we operated in a regular humidity environment. What we had was a road reconstruction. We assessed pollution that was happening. We were determining and trying to apply different models to try to correlate detected versus modeled concentration levels. We also took the wind direction as one of the top reasons, and we put our sensors at the human height so we can see directly on average human size how much these particles actually come to our breathing system. This is the sensor we used, and this is how it actually showed on our computer. This is the road reconstruction that we monitored. And this is what we actually tried to check. We tried to see if Tier 1 EPA prediction model can be applied for predicting possible concentration levels during the construction sites. We used for advanced modeling because Tier 1 can only show you a daily average. We used advanced modeling system software called ADMS Urban, and we got results here in the first line. In this line, we have measured results for PM10 and PM2.5, and we have predicted results in the second line. As you can all see, AMDES Urban showed much higher predicted concentrations. But when we try to connect Tier 1 EPA modeling calculations, we got similar results. As you can see, for PM10 particles, we actually have similar results. And we found that Tier 1, you also checking different locations later, we discovered that tier 1 can be applied for PM10 particles. But if you can see here, for PM2.5 particles, this connection is not applicable right now. So we needed to create some correctional coefficient. For PM10, it would be 0.916, and for PM2.5 particles, it would be 2.5, for example. But problem, where is the difference? Why is the tier 1 model problematic for PM2.5 particles? Problem is that EPA decided, and in their calculations, found that 2.5 particles are only 10th part of the PM10. And that is where we found the problem. So we learned that we need to make some different calculations and to take some different stuff into considerations. And as for our final remarks, as I just said, so we have gaps in tier 1 prediction model. The biggest gap is for PM2.5 particles, and it is very problematic gap. And we believe that with additional modeling, monitoring, and trying to do some revisions and alterations in the model, we can find the proper correctional coefficient, which can be used later to create more precise model, so that we can have precision monitoring and prediction model. And why is PM emission modeling important? Well, for start, as I previously said, we have more than 200 active construction sites in Novi Sad. Now imagine every construction site polluting small part of the environment. And we are not talking about long-range transport of particles, just a short-range transport. So we are producing big problems with the small points. So it's like little by little, we are creating big problem, and we need to start addressing it as soon as possible. I would like to take our project. Project number, as you can see here, and the project name is Innovative Scientific and Artistic Research from the FTS activity domain. And I would like to thank my colleagues for participating in this research. And also, I have a great pleasure to call you all at our department. We will organize as a part of bilateral project between Serbia and Slovakia. Last year, we had some test conference. And this year, we will have a small student conference. And I would like to ask you all to participate, to send us your abstracts. For more information, feel free to contact me, because we are trying to encourage students for PhD studies and young researchers to come here to try to speak, to get an opportunity to speak, to exchange ideas, to try to show their current research results, and of course, so we can all expand our science and professional networks, so we can learn who are our colleagues, to get another idea about our research. And what is very important for our project, for our conference, is that participation is free. So everybody is welcome to participate. For any information, anything you need, you have my email here, and feel free to contact me. Thank you.
Okay, thank you so much. So can I ask if Portuguese students, PhD students, can participate in your conference, or it will be only for Serbian and
No, yeah, it is going to be international conference. It is organized by Serbian and Slovakian professors, but we will also have professors from different countries and participants from different countries. So it would be international conference. In Serbian ranking, it would be M34. So we are openly
Okay.
inviting everyone.
Okay, thank you. Thank you very much for your nice talk. Since we are talking about dissemination activities, I was wondering if you plan to have some dissemination activities to increase perception and awareness of the workers and of the building companies to the importance of this issue, mainly because of the high levels of PM 2.5. So can you comment on that?
Yeah, of course. This is part of my PhD research, and I think it will be really shortly finished. So I think I will defend during the beginning of next year my PhD thesis. So after that, yes, about dissemination, I'm planning to create. Actually, we tried to get few projects, but we didn't succeed yet. We tried to get projects, and one part of dissemination of these projects was creating not a rule book, but like guidebook for particle emission on construction sites, how to mitigate the possible emission when we see it and how to predict it, where to expect it. So yes, I'm planning to create this one way or another. If we don't get projects, we will find funding somewhere else. But yes, this is important. And actually, this morning I spoke with a few of my friends. We were talking about environment and everything, and our conclusion about everything is that we need to start making changes from ourselves. So I believe that we can make difference, and we need to start making it by ourselves. We cannot expect from government or big companies to do it. We need to address them, try to talk with them one by one. But as I said, one building site is not problematic, but if you have 10, 20, 200, we are creating a lot of pollution, and our city is still a small city for that amount of pollution.
Yes, but it's a very beautiful city. Novi Sad, it's a very beautiful city.
Yes.
That I know. Yes, that I know. You have, I think you have already replied a little bit about because of the guidelines, but you have a comment in the chat. I don't know if you are able to read it. So this is from Rock Novak. That congrats you to because of your nice presentation.
Yeah, I can see it. I can read it. Okay.
Yeah.
Well, first of all, part of my PhD thesis is creating models and methods for particle emission and mitigation. So I analyzed a lot of developed countries, let's call them like that, like China, UK, USA, European Union, India. We analyzed regulations and what they are doing. So basically, I believe that if I become a mayor of Novi Sad, but maybe somewhere in the future, yes, we need to address differently everything. So we need to create good regulations. We need to create regulations that predicts pollution. Not only say, okay, now we have pollution, what are we going to do it? But prevent it in projects, during project processes. So when we are doing a project, for example, I'm as architect, design some building. I cannot design building and not think about pollution that I will create. So I think we can implement different laws and different regulations, and we can educate our engineers without have to penalizing them. But also we need to educate our inspectors, and everybody needs to be on the same side. We need to realize how great pollution can be and how much damage can it done.
Okay, so thank you very much.